down this because like how?
So anyway, these are complementary, supplementary angles. Adjacent angles are next to each other and they share a ray. Non-adjacent angles do not. So they don't share a ray. So I see some adjacent complementaries, non-adjacent complementaries, and I see some adjacent supplementaries and non-adjacent supplementaries. But either way, if they add up to 90 degrees, you're getting complementary. If they add up to 180, you're getting supplementary. We have a new word here called linear pair. Linear pairs are adjacent supplementary angles. So I've got this line right here, and then I've got two angles that kind of make up the line. So these two angles that are adjacent are called a linear pair. If they're not adjacent, these over here are not linear pairs, but these two are. 5 and 6 are, 7, 8 are not. Another very important kind of angle to know are vertical angles. Vertical angles. Has anybody heard that word before, vertical angle? What is it? What's a vertical angle? An angle up and down. Well, yeah, yes. They could be side to side too, though, right? They can be. Vertical angles, if you look, see the X formed by these two lines? The vertical angles, I guess you can call them opposite angles, maybe? So those two, 4 and 5, those are vertical angles. But you know what else are vertical angles? 3 and 6, those are also vertical angles. So you make the X into the opposite. Vertical angles. And I'm going to give you a sneak preview because what's helpful to know is that vertical angles are congruent, always. And we're going to prove that soon. It's just information about vertical angles. Yeah?
So 8 over 4 and 5 are equal?
Yes, they have equal measure. They're not equal angles, but they have equal measures. Tell me, do I have any linear pairs contained in here? Are there any linear pairs that we see in this diagram? Which angles are linear pairs? Yeah. 3 and 4 make up a linear pair because I can see that line form. Are there any others? Yeah. 5 and 6 linear pairs. Any others? Yeah, Isa. 4 and 6 linear pairs. Any others? 3 and 5. Okay, so we have linear pairs, we have vertical angles. Do I have any adjacent angles? Any adjacent angles? Do I have adjacent angles? 3 and 4. Next to sharing a ray. Do I have any non-adjacent angles? What do you say? Yeah, 4 and 5. So vertical angles are non-adjacent. They're not next to each other, and they're not sharing a ray. They're not. They have a common endpoint, but that's about it. So those are what we have to know. Complementary, supplementary, adjacent, non-adjacent, linear pairs, and vertical angles. What else we got? Angle pairs. So let's see. We're going to find the value of the variables and find the measure of each angle. So what kind of angles do I see here? What are those? What are those?
Supplementary.
They're supplementary. Why are they supplementary?
Because we'll add up to 180.
Well, how do I know that? How do I know they're going to add up to 180? How do I know that? It's a straight line. This is a straight angle here. Straight angles have a measure of 180 degrees around. So they are supplementary. What else can I say about what I'm seeing here? Yeah? They are a linear pair, and these two angles are adjacent. We've got all those words here. They are adjacent. They are linear pair because they're part of this straight angle, which means it's 180 degrees if I add these two together. So if I want to find the measure of each angle, how do I go about doing that? How do I go about doing that? Yeah, what would I do?
Could you 7x minus 3 plus 12x minus 7 equals 180?
Yeah. This is, you can add up the two angles, and I know that it's going to add up to 180 degrees. So now I'm going to combine my like terms, 7x plus 12x minus 10. I'm going to add 10. 19x equals 190. So x equals 10. Okay, so am I done? Have I answered the question? No. What do I need to do?
You need to find the value of the
Yeah. Because always read what the question is asking. It says find the measure of each angle. So I have to plug the 10 in. So angle, or the measure of angle want the measure of angles. We put an M in front. And now I want a number. What's the measure of this angle? It's 67 degrees. Without the little m, I'm talking about the physical angle itself. It's kind of like when we had the segment with the bar on top, that's the physical segment. And if I have the segment without the bar, I'm talking about its length. So same kind of idea here. Let me do this side. So let's see, 12 times 10 minus 7. 120 minus 7. Okay, 113. So the measure of angle GEF equals 113 degrees. What would be a smart thing to do before I leave? Yeah. What an excellent question. She's saying, I know that this is 180. We figured out this is 67. Can I just do 180 minus 67? What do you guys think? Yeah. What do you think? Yes, that she thinks like me. Yes. Now, there's nothing mathematically wrong with what you suggested. What, though? What would happen if you made a mistake doing the calculation? You did 7 times 10, you wrote 17. Anybody ever do stuff like that? I do. And so you got 14, you put it here, you did 180 minus 14. You're happy, right? You think you have it. So if instead, you take the x, plug it in here, I'm getting 113. Then add. This is your check. Does it add up to 180? Okay, now I know I didn't make a mistake. So yeah, technically, yes, you can do that. I would recommend not doing that. I would put the x in here, I would put the x in here, and I make sure it works. Because if it works, then I know I've got the correct value. So that's a great practice. I'm glad you asked that. All right, let's look at this one now. Find the measure of the angle, each angle. Well, I already know this angle. What's the measure of angle HEG? 90. How do I know that? Little box, right? It's telling me that's 90 degrees. Now I gotta find these. How do I do that? How do I do that? I do. So what kind of equation can I create here? And how did you know they equal 90? Well, this little square is over here. So what do I know about this one then? Because there's no little square there. Because this is a straight angle. If half of it is 90, there's no other possibility. That must be a 90 as well. And we're going to actually prove some of these things at some point, but you can tell it's just kind of obvious. So if 6x plus 4x is 90, that means 10x is 90, so x is 9. Again, I'm not done yet. Read the question. What are the angles? Okay, so, 6 times 9, that would be the measure of angle DEG. It's going to be 6 times 9. That's 54, right? And then I want the measure of angle GEF. And what's that going to be? 4 times 6? 4 times 9? Come on, 36. Add it up. Just make sure. Yeah, I got it right. The little degrees are actually important. So you do need to put the degree unit on there when you're measuring angles, because there are other ways to measure angles that don't use degrees, so we don't want to kind of mess that up. Another point I wanted to mention was, remember I said you could call it by the vertex? Right? You could call the angle by its vertex. That's what we said on the original slide. Can I call this this angle in here? Can I just call that angle E, because that's its vertex? Can I do that? What do you think? Why not? Yeah. So when I said you have to be careful that it's not ambiguous. You know what ambiguous means? Ambiguous means kind of unclear. So angle E is a vertex. It's how many different angles? It's this one, it's this one, it's this one, it's that whole thing. It's even the straight angle. Look at all the different angles that have E as a vertex. So if it's unambiguous, you could use angle E. But if it's not clear which one you mean, you have to use the 3-letter way. Or you could put either a small letter in here, angle A, angle B. We use numbers sometimes. This is angle 1, this is angle 2. But as long as it's very, very clear what angles we're talking about. So be careful just naming them. And then what else we got? Oh, no. We're going to do this. What are we going to do?
Oh, no, I have a question. For the second one we did, you said that the only 2 angles used to be supplementary, so how come it
Well, you know who's supplementary? DEF is supplementary to DEH. Who's complementary? Yes, DEG and GEF. But yes, he's trying to catch me. He's good. You should do that. But look at this guy. You have an idea? Okay, so we're finding a linear pair into one variable. Linear pair in one variable, I can add them up, and I get 180, because linear pairs are part of straight angles, so the whole thing's going to be that. Oh goodness, what's this? That's 11x plus 26 equals 180. Oh, no, I'm going to subtract that. This 160, 154. No, that's not right. Is that right? 154? And then I gotta divide that by 11, really? Well, I think that's 14. Isn't it? Yeah. Okay, so x is 14. So can I find these angles now? So this one's gonna be 3 times 14. Oh, I do know what that is. 3 times 14 is 42 degrees. And this one is gonna be 8 times 14 plus 26. I'm glad I did some of these ahead of time because I can't do this in my head. 138 degrees. Does this add up to 180?
Yes.
Good, right? Do that little check. Takes a second. Just make sure. It'll let you know if you made a mistake with your x. Yeah.
Are the opposite?
They are. So what do you say?
So like the one that says 5y plus 38 and 8x plus 26 plus 15 minutes.
This one? Yeah. And this one are equal. You could. That's only because I told you that secret array. I wasn't supposed to let you know that vertical angles are congruent yet. So what if we didn't know that little secret? Well, how else can we do it? Yeah. So I've got another linear pair there. This time, I think I know what that is. It's 42. So I'm back with just one variable. 5y plus 80 equals 180. Subtract the 80. Oh, I'm doing it right. Gotta catch my math errors. I'm getting y is 20. Let's see if it works. So 5 times 20 plus 38. That's 100 plus 38. Look at this. Getting back to the 138 degrees. So it did work. The vertical angles are congruent. You can get at it another way by looking at the linear pair. So we can get at them sometimes more than one way. And we can find the different angles. Got a question?
Would 3x with the top one without any of the,
Yeah, what's this one going to be?
would it be a vertical angle with 3x?
Yeah, so what's his measure going to be?
3x,
Well, which is,
42.
yeah, he's going to be 42 as well. Yes, and he's 3x. Absolutely. So it's a little secret. I wasn't supposed to let you in on that yet. But it's true. Vertical angles are congruent. And you can use all that information. Fantastic. The protractor postulate. We had a ruler postulate. Remember the ruler postulate? This says you can use a ruler. That one said that, you know, if you have this value is x1 and this value is x2, if you want to find the distance, it's x2 minus x1, right? Just distance. So this is doing the same thing. So you can use a protractor, and if you want to find this angle, you take his measure, and then you subtract this measure. Now, when we use a protractor, we like to start with 0. Because that makes it easy. I'm subtracting 0, so I don't even have to look at this number. What is the measure of the angle, by the way? What? What is it? 140, right? Not 40. So make sure it makes sense. This is an obtuse angle. We're opening this way. I'm going to use that scale, starting with the 0. All right, that's the protractor postulate. The angle addition postulate, we've used it already. It's kind of like the segment addition postulate. Remember that one? So segment addition postulate says this piece plus this piece will give you the whole piece. The angle addition postulate, same kind of idea. You have an angle, and there's, you know, something else going through here. They're adjacent angles. This piece plus this piece equals whole piece. Okay? And we've already used it. We've already used it in figuring out some of these other things. So let's use the angle addition postulate. I'm going to read on page 2 here. Given that the measure of LKN is 145 degrees find the measure of LKM and measure of angle MKM. Page 2 here. Again, this little m is important. If you don't have the little m there, we're talking about an angle, the physical angle itself. So I want the measure, I want its degrees. So let's see, what can I do here? So always mark up the diagram. Don't be afraid of writing on your diagram. Once you do that, you can see stuff. So LKN, that's this angle. And its measure is 145 degrees. Mark up the angles on your thing, because I want you to get used to writing all over them. Find the measure of LKM, and what's that? This is LKM, that's over here. And find the measure of MKM, where's that? So kind of identifying the angles, that's kind of important too. So what am I trying to do? Oops, angle addition postulate, right? This little red arc plus the little green arc is going to give me my blue arc. So that means that 2x plus 10 plus 4x minus 3, that's going to give me the measure of the big arc, which is 145 degrees. And now we're just equation solving. 6x plus 7 equals 145. So what do I have here? 6x, 138. And so x equals 23. Yes, it does. Okay. Now I have, again, don't stop. If they ask for x, I can stop. Did they just ask for x? No. I want the actual measures. So the measure of angle LKM equals 2x plus 10. Here's that's 23. So is it 46 plus 10, 56 degrees? That's what I'm getting. Now I could say 145 minus 56, but I don't want to do that. I want to really work this one out. The measure of angle MKN equals 4x minus 3. So 4 times 23 minus 3. 4 times 23 minus 3. That's 89. That's not as bad. Yeah. Okay. So, and then this is my check. I like doing it separately because now I'm just going to add them. What do they need to add up to? 145. So it's a 15. Oh, good. Right now I have a lot of confidence that I'm doing that right. So this one in here was 89. This one's here 56. Whole thing 145. Right? Makes sense? Questions? Okay. What else are we doing? Okay. Angle congruence. So again, I feel like we really kind of have to beat over the head a little bit the difference between congruence and equality. So two angles are congruent if they have the same measure. And also, if two angles have the same measure, they are congruent. This is kind of an if and only if. It works both ways. It's a biconditional. Don't confuse it with equality. Equal means same. Congruents are clones. So two physical angles, they're congruent. There's two of them, but they're very identical. What is equal is what they measure. So if this one is 45 degrees, then this one is 45 degrees. That's equal because that's the same. 45 is 45. So we use measure of angle A equals measure of angle B because these can be equal. But if you have two angles that have the same measurement, the angles themselves are congruent. Questions about that because it can be very subtle difference. So far we think we're okay. Good. So here's an example. Write a statement meaning two congruent angles. Then write an equality statement describing two angles that have equal measures. So middle of page 2 here. So what do I mean here? So for example, I'll do one of them. These little arcs denote congruence. So notice how this has one arc, this has one arc. They're congruent. This has two arcs, this has two arcs. They're congruent. Yes? Two angles are not, well, two angles are equal if they are the exact same angle, right? But the measures can be equal. So let's look at these two. These are congruent angles. Are they the same angles? Angles be exactly, is it the same as them? They're two different angles. They are congruent though, because they have the same measure. Now it's not saying what their measure is, so let's make up a number. Let's obtuse. Let's make it 120. Let's pretend they're 120 degrees. That's the same number. Is 120 the same as 120? Their measures are same. That's why their measures are equal. But the angles themselves, they are different. In fact, they're kind of, they wouldn't even fit one on top of the other because they are kind of inverses of each other. They're reflections, right? But they are congruent because their measures are the same. What would be another set? There's another set where you can say the same kind of thing. What do you think, Michelle? Angle L is congruent to angle M. There they are. They're congruent because why? Their measures are equal. Kind of a subtle difference. But their measures are equal, therefore they're congruent. And if they are congruent, then their measures are equal. It is a biconditional, goes both ways. Still questions about that difference, because it's going to become important. Yeah? Okay. Another thing we want to discuss here are angle bisectors. We talked about segment bisectors. What does a segment bisector do? What does it do? Right. It divides the line into two congruent pieces. So what do you think an angle bisector does? What does it do? What do you think? Divides the angle into two congruent pieces. And I mean, if I use one arc, that means they're congruent. I could have given them both two arcs. So the number of arcs will help you figure out what is congruent angles. So let's see, a little problem here. So suppose this ray YW bisects angle XYZ. And measure of XYW is 18. You know what? I don't even finish the question. I got to draw it. I have to draw an angle. So I have an angle, and it's X, Y, Z. Remember that we always put the vertex in the middle. And YW. So here's Y. It bisects it. It's going to cut it into two congruent pieces. I'm going to put that here. And I'm putting arcs in right away. Bisects. Even though they look it, believe me. As long as I put my two arcs in, they are congruent. The measure of X, Y, W is 18 degrees. Find the measure of X, Y, Z. Right? That big angle. What's it going to be? Right? Then let's do that. So let's see, what do I know? I know this one's 18. So this is an angle bisector. They're asking me to find the big angle. So the measure of angle XYZ is going to be 36 degrees. You can draw a picture. I think that unless you are, there are some people who are kind of in this world where their whole mind just sees that picture. The mere mortals, you and me, well, I can't do it without a picture. Look how hard this is without a picture, and look how much easier it is with a picture. So draw pictures, draw pictures, draw pictures. Okay. What now? What now? All right, so I got the U tries. So I want you to kind of work these and see how it goes.